In this video, I'm going to talk about how to multiply and divide numbers in different bases. So for instance, if you want to do multiplication, for instance, in base 10, we know that's very straightforward, like 2 times 8, we know it's 16. But how do you do that in, let's say, in base 2 or in base 5 or in base 9? So this is what I'm going to discuss in this video. I'll talk about multiplication and division of numbers in different number based system. So I'm going to start with multiplication. So let's take a look at this example. So let's say you are asked to multiply 21 in base 3 by 12 in base 3. How do you go about this? There are different ways you could perform this or get this done. But one way is to convert each of them to base 10. So one way is to take this and convert to base 10, right? Convert this to base 10 to a number in base 10, then multiply them in the conventional way. Then that is to multiply this two, you multiply this two, then you convert the answer back to base 3. So you take the two, you convert them to base 10, multiply in decimal system, then convert the result back to base 3. So let's look at how to go about this. So the first thing we'll do is to convert 21 to base 10. And that will give you, this is 0 and this is 1. So that's how you convert to base 10. You indicate the place numbers, the place number. Then you take the first digit, which is 2, times the base raised to the power of the place, which is 1. Then plus 1 times 3 raised to the power of the position or the place of that one. So if you evaluate this, that will give you 3 times 2 raised to the power 1. 2 raised to the power 1 is 3. Sorry, 3 raised to the power 1 is 3. 3 times 2 is 6. Then 3 raised to the power of 0. Any non-zero raised to the power of 0 will give you 1. So in this instance, you have 1 times 1, and that will give you 1. So the answer is 7 in base 10. So let's convert 12 to in base 3. Let's convert that to base 10. So the position of this is 0, the position of this is 1. So you say 1 times 3 raised to the power of 1 plus 2 times 3 raised to the power of 0. If you simplify this, you are going to get 1 times 3, that's 3, plus 2 times 1, and that will give you 5. That's 3 plus 2, that's 5. And that's in base 10. So what do we do next? We take 7 in base 10 and multiply by 5 in base 10. And when you multiply anything in base 10, you just perform your typical, you just multiply the normal way we do multiplication, and that's 7 times 5. That gives us 35 in base 10. So the next thing is to convert this 35 in base 10 back to base 3. So you do it by taking 35 and you divide by 3 until you get to 0. So 3 in 35, that's 1, that's 3 in 3, 1, then 3 in 5, that will give 1. The remainder is 2. 3 in 11, how many 3 can you take out of 11? So that's 3, that's 3 times 3, 9. Then if you subtract 9 from 11, that gives you 2. So the remainder here is 2. Then 3 in 3, that gives 1. And the remainder is 0. There's no remainder here. Then 3 in 1, 0. Remainder 1, because 3 can go in 1. So it's 0. Then the remainder is that same 1. Okay, so the answer becomes 35 in base 10 is equal to 1022 in base 3. So this is how you convert, this is how you multiply two numbers in any given base. So the next step is, let's solve a question. Let's take a question from UTME, that's JAMB UTME. Let's take a question and see how to solve a question related to this topic. So to extract question in TestRader, you go to question search. Go to question search and you select the subject you want to search. Then in this case, the question I'm interested in is mathematics and I want to search by topic. I want to search a topic. Then I'm going to select number basis and then search. So in this particular case, I'm interested in question 5 of the year 2003. Question 5, 2003. So if you take a look at this question, you will see that we are asked here to do a multiplication of two numbers in base 4. So how do we go about this? How do we solve this? So let's take a look. You have 213 in base 4 times 23 in base 4. So what do you do here? You convert each of them to base 10 first. And let's see how that works out. So 213 in base 4 we convert to base 10. You first indicate the place number, this 0, this 1, and this 2. That's the position. And then you solve. So you say 2 times 4 raised to the power of 2 plus 1 times 4 raised to the power of 1 plus 3 times 4 raised to the power of 0. Then you evaluate the whole expression. So 2 times 4 raised to the power of 2 is 16. Then 2 times 16 will give you 32. Then plus 1 times 4, that will give you 4. Then plus 3 times 1, that will give you 4 raised to the power of 0 is 1. Then that will give you 3. And let's add everything up. 32 plus 4, that's 36 plus 3, that will give us 39 in base 10. So let's convert 23 in base 4. Let's convert to a number in base 10. So this is 0 and this is 1. That's the place number. So you take 2 times 4 raised to the power of the place number, which is 1, plus 3 times 4 raised to the power of the place number, which is 0. If you evaluate this, you're going to get 2 times 4, that's 8, then plus 3 times 1, and that will give you 3. This we add up to 11 in base 10. So the next thing is to multiply 39 by 11 in base 10, both of them in base 10. You can use your calculator to do the multiplication, or you can use the shortcut that I learned some years back. If you want to multiply a number by 11, you separate the 3 and the 9. You separate this, you take this unit out and you take the rest to the left. Then you add them up. Just add up 3 plus 9 and that will give you 12. Then you write 2. The remaining one, you take it to the one on the left. So you add it to the one on the left. That will give you 4, right? That's plus 1. So that will give you 4, 2, 9. So it means 39 times 11 equals 429. So this is just a way to multiply any number by 11 without a calculator. So this is 429 in base 10. So the next is to convert 429 in base 10 back to base 4. So how do we go about that? So let's get it done here. So here you have 429 and we want to convert to base 4. So you keep dividing by 4, right? So 4 in 4, that's 1. 4 in 2, that's 0. Then in 29, that will give 7, right? That's 28. So if you subtract 28 from 29, so the remainder here will be 1. So the next thing is to divide further by 4. So 4 in 10, in this case, that will give you 2. Then remainder 2, right? In 27, that will give you 6. And 4 times 6, we know is 24. If you subtract 24 from 27, that's 3. So the remainder here is 3. Then 4 in 26, if 4 in 26 is 6, that's 24. Then if you subtract 24 from 26, the remainder you will get will be 2. Then 4 in 6, that will give you 1, remainder 2. Then 4 in 1, that will give you 0, remainder 1. So you go this way and you take those numbers. So it means 429 in base 10 is equal to 1, 2, 2, 3, 1 in base 4. So this is the answer. So let's check what the correct option is. So if you take a look at this closely, you'll see that option B is exactly what we got, which is 1, 2, 2, 3, 1 in this form. So now let's talk about how to divide numbers in different base system, or divide number with a different base other than 10. So let's take a look. Our next discussion is on how to divide numbers in different base system. So let's take a look at this example. So let's say we have 1, 1, 1, 0, 0 in base 2, and we want to divide by 1, 0, 0 in base 2. How do we go about it? We apply the same principle as we did for multiplication. We convert each of these numbers to base 10. We do our division in the regular fashion, and we convert back to base 2. So let's convert 1, 1, 1, 0, 0 to base 10. So the base number is 0 here, this 1, this 2, this is 3, and this is 4. So we say 1 times 2 raised to the power of 4 plus 1 times 2 raised to the power of 3 plus 1 times 2 raised to the power of 1. 2 raised to the power of 2 rather, and plus. Note that whenever you have 0, whenever you are multiplying by 0, you can ignore them. So instead of saying 0 times 2 raised to the power of 1, you can just ignore them because every other thing will be 0, right? So in this case, you have 2 raised to the power of 4, that's 16. Then plus 2 raised to the power of 3 times 1, that will give you 8. Plus 1 times 2 raised to the power of 2, that will give you 4. If you add up all this, you are going to get 16 plus 8, that will give you 24 plus 4, that's 28 in base 10. So let's do the same for 100 in base 2. Let's convert to base 10. Is 0, 1, 2, right? So you say 1 times 2 raised to the power of 2. You can ignore the rest since the rest are zeros, right? You can ignore the zeros because they will end up giving you 0 and they won't contribute to the sum. So this is 1 times 2 raised to the power of 2, which will give you 4 in base 10. So the next thing is to perform the division in base 10. So in this case, I want to say 28 divided by 4, which is basically 28 over 4, and that's 7, right? So we convert this 7 in base 10 back to base 2, and that will give you 2 in 7. That is 2 in 7, that's 3, remainder 1. Then 2 in 3, that will give 1, remainder 1. And 2 in 1, that's not feasible, so it says 0, remainder 1. So now we can say the answer is 7 to base 10 is 111 base 2. So we can say that 11100 to base 2 divided by 100 to base 2 equals 111 to base 2. So this is how you divide numbers in base 2 or base 3 or any other base. Okay, so the next topic is solving for an unknown base. So let's say you have a situation where you were asked to determine what the base is, given that you know the answer. How do you go about it? So let's talk about that next. Let's talk about solving for unknown base. I'm going to tackle this problem by exploring past questions from both JAM UTME and WAS. So let's start from JAM UTME past question. So I'm going to take question number 1 from year 2005. So if you take a look at the question, you will see that the question says find the value of m if 13m plus 24m equals to 41m. So here we have 13m plus 24m equals 41m, and the question is for us to determine the value of m. So this is how we go about it. We try to solve it using the m, then we collect like terms and we use algebra to eventually determine the value of m. So I'm going to go ahead to solve it. So you have to convert each of them to base 10. So that's the logic here. So you have to take this to be 0 and this to be 1. That's the place number. This is 0, this is 1, and this is 0, this is 1. So for 13m, for 13 to base m, we are going to say that 1 times m raised to the power of 1 plus 3 times m raised to the power of 0 plus 2 times m raised to the power of 1 plus 4 times m raised to the power of 0, and that's equal to 4 times m raised to the power of 1 plus 1 times m raised to the power of 0. So what's 1 times m? That will give you m. Note that as long as m is not 0, m raised to the power of 0 is equal to 1. So we can say this will give you 3 times 1. So that's 3. So the same applies to this. So you say 2m, then plus 4 times 1, that will give you 4. Then the same 4 times m, that's 4m, then plus 1 times 1, that's 1. Okay, so the next thing we want to do is to collect similar terms, things that are similar. So here, you take all the m to the left, you take all the numbers to the right. So here you have m plus 2m. If you when you transfer 4m to the other side, it changes sign. So from plus 4m, it becomes minus 4m, and that will be equal to 1. When you transfer 3 to this side, it becomes minus 3. When you transfer plus 4, it becomes minus 4. If you add up what you have on the left, that will give you m plus 2m, that gives you 3m, minus 4m, that gives you minus m. Then here you have 1 minus 3, that gives you minus 2. Then minus 2 minus 4, that gives you minus 6. So we can simply say, if you multiply both sides by minus 1, you're going to get m equals 6, right? So the value of m is 6. So m actually is 6. So the correct answer here is option B. Okay, so let's move on to another question. I'm going to pick a question from that's WAS examination. So let's take a look. Okay, so in this case, we're going to take question number 6B, and that's from 2002. WAS past question 2002, and the theory question. So this is a theory question that was asked in the year 2002 by WAEC. That's question number 6B. So let's take a look. So the question says, if 123 to the base y is equal to 83 to base 10. So the question says we should obtain an equation in y, and we should also solve for the value of y. So in this case, we are actually looking for an unknown base. We don't know the base, which is y. So how do we go about this? You can easily solve this by applying the same principle as we did earlier. So you convert what you have on the left to base 10. So how do you do that? You indicate the place number, which is 0, 1, and 2, and then you take 1 times y raised to the power of 2, right, plus 2 times y raised to the power of 1 plus 3 times y raised to the power of 0, and that gives you 83, which is in base 10. So both sides are now in base 10. So 1 times y squared will give you y squared, then plus 2 times y raised to the power 1, that's 2y, then plus 1 times y raised to the power 0, which will give you 3. 3 times y raised to power 0, which will give you 3. And that's equal to 83. So if you try to simplify further by taking what you have on the right to the left, that gives you plus 3 minus 83 equals 0. So y squared plus 2y is minus 80 equals 0. So this is the equation. So the second part of the question is for us to determine the value of y. So this is a quadratic equation. We can't use basic linear equation principle to solve this. We have to use knowledge as regard quadratic equations to solve this. We can use different method. We can use formula method and so on. So I'm going to use formula method for the sake of simplicity. So to solve a quadratic equation using formula method, you should note that the general formula is written as if you have an equation of this kind, ax squared plus bx plus c equals 0, x will be equal to minus b plus minus square root of b squared minus 4ac divided by 2a. So what this implies is to get the value of x, we can simply apply that formula to get our answer. So in a particular instance, the value of a in this case is the coefficient of y squared. So in this case, a is the coefficient of y squared, which is 1. B is the coefficient of y, which is 2. And c is the constant, which is minus 80. So we can use this quadratic formula to determine the value of y as follows. So we have minus b, which is minus 2, plus minus square root of b squared, which is 2 raised to the power of 2, then minus 4 times a, which is 1, times c. C is minus 80, right? Then everything divided by 2 times a, which is 2 times 1. So if you try to simplify this further, means you're going to get y as minus 2 plus minus. So here you have 2 raised to the power 2, that's 4. Then sorry, this is 4 times, this is 2 squared rather, sorry. Then here you have 4 minus 4 times 1, that will give us 4, times minus 80. So that if you multiply minus 4 times minus 80, that will give plus 320, that's 320, divided by 2. So the next thing is to determine, so you can simplify further as follows. You have 324 divided by 2, then you simplify. So what is the square root of 324? The square root of 324 will give you 18. So that's minus 2 plus minus 18 divided by 2. So that will give 16 over 2. So that's 16 over 2 if you decide to take the plus, or if you decide to take the minus, it will be minus 20 over 2. So because it could be plus 18 or minus 18. So that will give you 8 or minus 10. When dealing with number bases, you don't take a negative value. The base of a number can be negative. So we accept only the positive answer as the valid result. So y equals to 8. So that is basically how to solve for an unknown base in a situation where you have uh, in a situation where it leads to a quadratic equation. So let's look at another section of number base, which is solving for unknown number. So this time around we know the base, but we don't know the number. So let's take a look at how to solve this such problems. Next, we'll talk about solving for unknown numbers. So in this case, you may have a situation where you don't know the number, you know the base, but you don't know some of the digits in the number. So let's take a look at an example. So I'm going to talk about an example in UTME question 10 of 2000 and of year 2000. So let's take a look at the question. So in this question, we have P 3, 4, 4 in base 6 minus 2, 3, P 2 in base 6 equal to 2, P 2 in base 6. So the question is, we should find the value of P. So P is not the base this time. P is a number, is part of the digit of the number. So how do we solve for this kind of situation? So the same principle we're going to apply here. We're going to try to convert to base 10 and then solve our way. So we just convert to base 10, then we try to collect like terms, then we solve for the value of P. So let's take a look. If you convert each to base 10, you are going to get the following. This 0, this 1, this 2, and this 3, right? So this P times 6 raised to the power of 3 plus 3 times 6 raised to the power of 2 plus 4 times 6 raised to the power of 1 plus 4 times 6 raised to the power of 0. Then we want to subtract the following from it. 2 times, this is 0, 1, 2, 3, right? So this is 2 times 6 raised to the power of 3 plus 3 times 6 raised to the power of 2 plus P times 6 raised to the power of 1 plus 2 times 6 raised to the power of 0. Then we want to equate that to 2 times 6. This is 0, 1, 2, 3, right? So 2 times 6 raised to the power of 2 times 6 raised to the power of 3 plus P times 6 raised to the power of 2 plus P times 6 raised to the power of 1 plus 2 times 6 raised to the power of 0. So let's try to simplify. So 6 raised to the power of 3 will give you 216. So that means you have P 216P plus 6 raised to the power of 2 will give you 36, and 36 times 3 will give you 108 plus 4 times 6, that will give you 24, then plus 4 times 1, that will give you 4. Then you're going to subtract 6 raised to the power of 3 will give you 216. 216 times 2 will give you 432 plus 3 times 6 raised to the power of 2, and that will give you 3 times 36, and that will give you 108. Then you have plus 6P, then plus 2. And this we're going to equate to 2 times 6 raised to the power of 3, so which is 2 times 216, and that will give 2 times 216, and that will give 432. Then plus 36P plus 6P plus 2. So the next phase is to collect like terms and simplify. To make this operation much quicker, you try to look for similar terms. So since this is subtraction, this can easily cancel out this, right? Then we can easily, then once we've canceled this out, then we just add up the rest. So here you have 216P, then plus this is 28. 28 minus 4, 3, 2, then minus 6p, then minus 2 equals 4, 3, 2 plus 3, that's 6p plus 6p plus 2. So the next thing is just to collect like terms and simplify further. So I'm going to quickly simplify and show you the simplified form of this. So if you simplify, you're going to get 168p equal to 840. Then p will be equal to 840 divided by 168, and that will give you 5. So the value of p is 5, and that means the correct option is option D. So this is how you solve for unknown digits or unknown number in a number-based system. So the next the next topic on that number basis I'll be talking about is application. We'll be discussing how number base is applied in real life.